Well, welcome. This is the Pi and Kafka session, for those of you who are confused. My name is Danica Fine. I am a developer advocate at Confluent, and so that means I'm a Kafka person, right? I absolutely love Apache Kafka. I've got a long history of it. How many of you are currently using Kafka? How many of you are completely new to it today? Enough of you. Great. I love having a mix. That makes it way more fun. All right, so yeah, let's get into it. We're going to do some survey analysis today. For those of you who have been to one of my talks before, okay, let's back that up a little bit. There is one piece of information that you can extract from everything that I just told you already, and that is I'm obsessed with Kafka. I absolutely love using it for fun side projects and serious side projects, but mostly the fun ones, and today's going to be one of those fun ones. If you've seen me speak before, or if you've read any of my blog posts, you also know that I like houseplants. I have a problem. So usually I steal a plant from the conference, or I borrow one to bring on stage, but my colleague's daughter gave me this one. So this is Jimmy. He has to sit here for the duration of the talk, I'm sorry. So I like houseplants, but I'm not so one-dimensional, right? I like more things than that. We have other hobbies in life. I also like baking. I like cooking. I like making things. I feel like it's kind of like a science experiment. It's kind of relaxing for me. So of course, I had to take one of my few remaining relaxing hobbies and make it into a work thing as well. So how many of you cook or bake? Enough of you. Thank you so much. So you probably know, I feel like there's always that one person in the friend group or the family that you are relied upon as the baker, right? That's my problem. Anytime my friends invite me to dinner or my family invites me for holidays or whatever, they ask, what are you baking? What are you bringing? And I love to do it because, right, it's a fun thing to experiment with. It's a fun thing to play around with. There's a reason for me to telling you all this. So as someone who loves to cook and bake, right, holidays, right? Holidays are a big part of that. You know, you spend hours and hours and hours baking something nice for all the holidays, especially at the end of the year, definitely in the US. In the US also, we have something called Thanksgiving. And at Thanksgiving, it's just basically you're in a food coma for 3 days. That's the whole purpose of it. I know, the Americans, it's what we do. But for Thanksgiving, we make pies. That's a big part. That's like the culmination of the meal. Not like meat pies or whatever we refer to as in the rest of the world. A fruit pie, right? It's more likely than not a sweet thing, all right? So at the end of the year, Thanksgiving happens, and it's usually something that you do with your family, but also, since I don't live near my family, my friends do this as well, and I have many friend groups, and so we have things called Friendsgivings. And at Friendsgiving, you have to bring something, and so I am the baker, so I'm asked to bring a pie to all of these. Many, many pies with different friend groups, and yeah, it's just the obligation, you know, that I have to carry. So this is where our journey begins, okay? I promise there's a whole point to this. We're going to talk about pie for the remainder of this presentation. So buckle up. You may also be asking yourself, why specifically pie? Why is this important here? Well, I do cook, but you know, baking is my favorite thing to do. I think that everything I make is fantastic and delicious, and I'm sure you also feel that same way about the things that you make, because you put a lot of time and effort and love or something into it, right? But of course, all the people that I'm baking for, they have hopes and dreams and opinions and all of those weird opinions that they have on their own, sadly, and sometimes they don't like the things that I make, or maybe they have preferences. And so I figure even for something like a Friendsgiving, where I am out of the goodness of my heart baking something for my friends, I still want to please them, right? I want to bring something that the most people at that dinner are going to enjoy, right? And so I like to be prepared. So ahead of these dinners, I will ask my friends, okay, well, what would make you the happiest? What pie could I bring to this event to make you just, you know, to really put a cherry on top of this and make it great for you? But with a lot of dinners going on, that is a lot of annoying information for me to keep track of in probably a Google Doc. Or just write down on little Post-it notes and keep around. And then I have to ask it again and again and again for every sort of dinner that happens. So what am I going to do? This is the problem statement here, is that I'm annoyed writing down information. So I'm going to go out of my way to make this easier for myself. So Google Forms, all right. Well, I mean, when this came out, great. I was one of those people, absolutely, who sent a form for absolutely everything. Just it's convenient, it's kind of annoying. It feels very official sending a link to someone. Yes, fill this out. Tell me what you want for dinner, right? So that would make me look bad, so we're going to do something different, right? OK, Kafka and Telegram-based survey issuing application. That's oddly specific in the other direction, but I think it actually works for this. So again, if you've seen any of my other content, I absolutely love to combine my technical skills, my love of Kafka, with my other hobbies that I have in life. So I figured maybe creating a message-based application based on top of an app that everyone that I talk to has, Telegram, that could issue these surveys to them, capture this information, put it into Kafka, and help me figure out what pies I needed to bake for these events. That could be worthwhile in the long run. I think so. So before I get too deep into it, is this something that needs to be solved with Kafka? Because I know that's the question you have, right? So I'm going to be business Danica for a hot sec. Surveys are everywhere, right? And I feel that, personally, for the amount of information that we can get out of surveys, right, just as I'm speaking as a company, right? For the information that I could be getting from my customers and from my employees using surveys, I feel like we don't put enough weight on them. We don't pay enough attention to what we're getting out of them. And I guarantee, they are everywhere, right? I guarantee some of you have been approached by some survey in the past couple of days, right? After you purchase something online, they ask you how your experience was, or you get off a plane, you immediately get an email from the airline asking how the flight attendant treated you. You're going to leave this room today and put a green sticker in that bin. And yeah, those are all variants of surveys. And even internally, right? Even if it's not customer facing, at the end of every quarter, right? Your employer probably asks, how did your boss do this quarter, right? And hopefully it's good. So for businesses, surveys are a really great way to connect with customers, to connect with your employees, and just understand how these products, how your services, how other people in your company are performing, right? The only downside I've seen to survey analytics is that, they are kind of a second-class citizen. I feel like we don't really pay attention to them that much. They're an afterthought after these sort of services are issued. And even though this data is collected in near real time in most cases, right, commerce continues and these surveys are issued, most times we're not really analyzing them until much later, right? Weeks later or at the end of the quarter when we see if we've met our OKRs or whatnot. So it's a batch process thing, which is completely at odds with how we're capturing the data, right? And I think you all look like reasonable people, so I'm assuming we can all agree that data is more valuable the closer to when it's created, right? So this is problematic. And so that's my business pitch. This is a completely legitimate use case, okay? Survey analysis in general is something that can benefit from a real-time component, a real-time processing component, meaning that my absolutely ridiculous application that I want to build here to capture these survey responses and help me analyze them is completely valid, okay? And it can be extended to things beyond Pi, but again, we're going to focus on Pi here today. So let's take this flow. So this is the general sort of recipe that we would follow to build a survey issuing and analysis bot with Kafka, right? So we need some way to actually capture these survey entries, right? Answer a couple questions, write that into Kafka. From there, depending on what your actual user base is, right? Are these customers that are taking the survey? Is it an internal thing? Are we getting this from, ServiceNow and your customer or your internal personnel database? That should also be in Kafka as well. Then as these entries flow through, we do a bit of stream processing, aggregate these results, maybe do a little bit more intense analysis if we need to, and then we want results, right? We want to know how these things are performing in real time. Okay, so this is the basic flow that we would follow for survey analysis, but we're going to make it a little more exciting. We're going to spice it up, right? Recipes, yeah, they're a science experiment, but generally you can take a base recipe and spice it up, right? Make it yours, make it more interesting, and that's what we're going to do today. We're going to focus on something like this. So I said I wanted to base this on Telegram, right? So you see a couple applications in there, but first of all, I need to maintain these surveys, right? The collection of surveys that I would like to issue. I'm going to write this data directly into Kafka. From there, I will build out the actual application to issue and then collect the entries from this surveys. And this is going to be built on top of a Telegram bot. That would then produce that into Kafka as well. And then we do a little bit of stream processing, combine those data sets with what the other metadata that I have available, and produce these real-time insights. At the end, I'm a lazy engineer, and I want this information directly on my phone. Okay, I don't want to look at once this is set up, I don't want to look at my computer ever again, right? And then hopefully at the end, I can make an informed decision on what ingredients I need to buy and what pies I need to make the next day, right? Okay, so at this point, I've mentioned Kafka more than enough. But too bad, there's going to be more of it. And at least a third of you raised your hand saying that this is your first time delving into Kafka. So sorry if you've working with it already. We're going to do a refresher. It's a huge part of the project, right? It's in the middle. It's the biggest part. So I want to make sure that we all understand what Kafka is and what you're getting yourselves into. I promise, this can be the best day of your life, okay? You won't regret learning about Kafka. All right, so what is it? It is a distributed event streaming platform. I love this definition. It's the most concise, the smallest definition I can come up with that adequately covers the important bits of Kafka. But there is a lot to unpack there, unfortunately, so we're going to spend the next 10 minutes doing that. All right, first of all, it's a streaming platform, and this word means different things in different contexts, but in the data context, not the Netflix context, okay? You may have noticed over the last decade especially that we're undergoing a paradigm shift in how we work with our data, how we process our data, how we store our data, how we move it. And so we're moving away from slower, maybe batch-focused systems where we're grouping data in chunks and then processing over that, and we're moving to real-time systems, right? We're stream processing. So again, instead of waiting to fill a batch of data and then group over that and process over that, we're building systems that can react to smaller pieces of data and produce incremental, actionable results in real time as that data occurs, as it's created, ideally, okay? And real time is a good thing, all right? It's why we're sort of moving to this shift. We want results in real time. It helps us build a better feedback loop in our businesses, right? And so Kafka is generally a technology that can help you unlock stream processing, okay? To move data as close to when it's created as possible and unlock these insights as that's happening. And so stream processing as a whole, I think it's pretty cool, personally. But there's a lot of technologies that you can use to do stream processing. It's not just Kafka. Kafka is just one of many of them. But generally, moving to stream processing has a lot of benefits. You're going to increase the accuracy of your data and your results. You're going to build a more reactive system, more an event-driven system. And in the case of Kafka, you can actually build a more resilient system and a loosely coupled system as well. Okay, so there are some benefits here. So Kafka generally is a system that enables this real-time stream processing for you, but it's not just that. On top of this, it could serve as a messaging system if that's all you need it for, right? Persistent storage layer as well, and as we'll see, a processing layer. And you can use it as sort of the central component of your system and pick and choose what aspects of that, what benefits you want to get for different pipelines and different applications as well. It is flexible, okay? But it is an event platform as well. It's not just for streaming. And for those of you who said this is your first time learning Kafka, this is the thing you need to write down and remember, okay? Because if you want to be successful with Kafka, it's an event streaming platform, you need to know about events. You need to be able to think in events and start reasoning about your data in this way, okay? And that might sound like a big ask, but I promise it's not, because you already do this. You already know how to think in events, because we are users, we are programmers, we are humans, and eventing, believe it or not, is just kind of how we're wired, right? Every time you submit an online form, every time you look at an application log file to debug something, every time you react to a notification on your phone, all of those things are events, okay? And so just be a little more aware of that fact. That's all I'm asking, okay? So those are examples of events, but what is an event actually? Well, it's something that has happened. I know, that's pretty profound, but that's all it is. It's something that has happened. And so what do you actually need to describe something that's happened? Well, you need to know when it happened. That's important. That's actually the biggest piece. You need to know when. You need to know who or what was involved, and then any other supporting details that would actually flesh that out, right? So if we're looking at this pie situation, that is a pie that I baked, by the way. It was very good. So we could say, if we're taking these surveys, right, I'm asking my friends what their favorite pies are. Well, an event would be, okay, maybe yesterday at 3:30 p.m., my friend Alyssa took the survey and she said her favorite pie was apple pie. Wonderful. Okay, that happened. She took the survey yesterday. Wonderful. So let's break it down. We have the timestamp, that really critical component. Yesterday at 3:30 p.m., she took that survey and issued her response. She took it, so we have maybe her represented as a user ID. She took this particular survey, which was a pie survey, and the supporting detail was that she said that apple pie was her favorite pie, right? So that's all those critical details that describe what actually happened in that moment yesterday at 3:30 p.m. Another key component of events that you will have to just grapple with and come to terms with if you're using Kafka well is that events are meant to be immutable. Okay? Once they're written to Kafka, you shouldn't expect to change them. Okay? And that's not me trying to be difficult or annoying. Immutability, I know, sometimes doesn't vibe well with programmers, depending on what paradigm you like to work within, but here we are. Events describe things that have already happened, okay, in the past, happened, right? So we can't change them, right? And we shouldn't really change them, because what we could do is we can add new events, right? We can fundamentally sort of update and change what has happened in the past by writing a new event, saying this is what happened now. So in this context, if Alyssa comes back to me today and says, well, I changed my mind, I'm not just being a difficult person saying, well, you can't change that entry. I just tell her, okay, retake the survey now. And then we write a new event that says today, later on today at 1 p.m. maybe, you can update your answer and say, okay, pecan pie, that's my favorite, I promise, done, right? And she can do that as many times as she wants, and what we're gonna do is we're just going to append another event to this timeline that describes these survey entries, or the state of her preferences over time, right? We're not going to delete any events, we're just adding new ones to this stream, all right? So based on that, based on what we just learned, right, you can probably see how Kafka is kind of cool, hopefully, so far. So first of all, it is a streaming platform. It facilitates the movement of events across your system for use in real-time processing. And it's also dealing with events, immutable facts, okay? And for those of you who are familiar with immutability, there's a lot of cool benefits you get from working with immutable data, all right? Namely, the way that we are storing this in Kafka, as we'll see in a little bit, it's really, really fast to append this data, right? It's really fast for us to replicate this data. And if we are monitoring for new things being added to Kafka, that's pretty efficient for us to do that too. And we can have as many downstream systems monitoring this information, tapping into it, and we can rest assured that the integrity of this data is being maintained, because it's not actually being updated ever, all right? There's a lot of cool things that you can get out of it. And I think it's pretty wild once you actually start working within those cool features. But how does Kafka actually help you move this data? How do you actually work with it in Kafka? Well, we got to look a little bit at the architecture. And it's a distributed system, for better or for worse. So the primary unit of storage in Kafka is a Kafka topic. It's usually a single data set consisting of these events that we just discussed. You write data into a Kafka topic using a client called a producer, and you write the data as key value pairs. So you have some sort of string and the event in question. You can have as many producers as you want, writing to as many Kafka topics as you want, within reason, but the limit's very, very high. It won't really matter. From there, to get data back out of Kafka, we use a separate client called a consumer. And again, you can have as many consumers as you want, reading from as many Kafka topics as you want. There are a couple other cool things about consumers, right? Because they're kind of the MVPs, right? They're the ones that are actually doing stream processing potentially. So the first thing is that as we're building up this, this topic worth of data, right? We're building up this timeline of events. A consumer that's consuming that data, well, a very useful thing for them would be able to keep track of where they've left off in processing, right? Because nodes roll, and we should probably be able to pick back up where we left off. And so consumers have this functionality built in. They use something called an offset, which is effectively just a bookmark. And this offset is tied to a specific event within a portion of the topic. So when they start back up, they can seek to that offset and continue moving on with their processing, all right? Consumers also have the ability to work together as something called a consumer group. And what this allows them to do is basically from a topic or a set of topics, they can potentially parallelize the processing of the data from those topics. But on the other hand, and this is where I think it gets kind of interesting because you are flexible in which one you choose, consumers can also be completely independent. That might not sound as interesting, but it's actually pretty cool when you think about it. They have the ability to just read all of the same data and do whatever they want with it, right? Because we are maintaining the integrity of those immutable events within the topic. And this is really, really important for those of you who did say you're new to Kafka, because it's very easy to compare Kafka to some similar technologies, right? Maybe a messaging queue comes to mind. And a Kafka topic is not a messaging queue, all right? Just nip that in the bud right now. It is absolutely not. The functionality is completely different. When the data is consumed, it doesn't go anywhere. That is the default behavior. And I want you to think of a topic as a log, because it is. It's a commit log under the hood. And so it's very similar to application logs, application log files, right? And you write lines to a log file. That data is there, well, until the log file rolls, right? Which is very similar to Kafka. And while the data's there, if you need to go debug something, you can go line by line through that file, build up that state of that application in your mind, and nothing happens to that information, right? It doesn't go anywhere. And so if at a later time your colleague needs to come by and wants to help debug or debug for a different reason, they are free to do so, okay? It's not going to impact any other person reading that file or trying to get that information. And as a side note, every line in a log file is an event, right? It has a timestamp. It describes something that has occurred on some area of that application, right? All right, so a Kafka topic is a log, a commit log. Keep that in mind. Consumers are completely decoupled from producers. This is very beneficial. We want to maintain loosely coupled systems for the most part. So what this means is that the producers, when they're writing data to Kafka, they don't care who's going to be reading it, if anybody is reading it, or when that's going to happen. They don't need to know. It's not important. Consumers don't care where the data is coming from or how often it's being written. They're just trying to read from a given topic. Okay? And so if we have a full pipeline of produce and then consume, if a producer stops for any reason, the consumer is still going to maintain its connections, right? It's going to wait for new messages. Okay, it's not going to crash and burn like the producer may have. Okay. Kafka topics, very important, are broken down into smaller components called partitions. An example of that is on the right over here. So we have a topic broken into 3 partitions. And what this means is that as we write data to a topic, we take the key of that data, if that exists, hash it, and then we know which partition it's going to be written to. All right, so we're guaranteeing ordering on keys, and we're guaranteeing that keys, messages with the same keys are going to be written to the same partition. All right. And these partitions themselves are actually the append-only logs of immutable events where the data is actually stored. And since Kafka is a distributed system, we're going to take these partitions and we're going to store them across the cluster. And there are some benefits of this, right? We're going to be able to replicate this data better, and this is going to provide better resilience. Okay? And going into this just a little bit more, because I think this is very important to understand this structure. So here's an example of a Kafka cluster. We have a couple of nodes here. The nodes of a cluster are called brokers. You can run them wherever you want, right? It can be VMs, bare metal, containers in the cloud. I don't care where you run it, just run it somewhere, okay? So very simple cluster with 3 brokers. We have 3 topics spread across them, and they have some number of partitions, right? So the results may vary, but this is an example of how they might be distributed. Why bother putting them on different nodes? Well, you don't want to bog down the brokers, right? If we stored all of the data on a single broker, well, then that means that for all of our producers that might be writing to that particular topic, they're going to be maintaining those connections to that broker, and they're constantly going to be bombarding it with requests to write that data. Okay, and similarly on the consumer side of things, they're going to be making requests and maintaining connections to that broker to get data out. So it's just beneficial to spread this data across the cluster as evenly as possible, so as to not bog down these brokers. And it also helps us serve up the data faster later on, and also helps us write it faster as well. Okay. So the overall goal here is to just distribute this data as evenly as possible. That's the bottom line. So this is great, but it's a distributed system, so nodes are going to go down. What do you do? Well, we've lost 3 partitions. That's a shame. not ideal. Thankfully, we've only lost a third of our data, right? We could have lost it all, but we didn't. We only lost a third. But we're going to take it a step further because that's not good enough, right? And we're going to use something called replication, which is a configurable parameter that just defines how many copies of a partition should we have across our cluster. So we're going to still look at this 3-node cluster from the perspective this time of just a single topic. And this single topic has 3 partitions with replication set to 3. That's sort of the default value. So with replication enabled, what this means is that we have a set of lead partitions. You see them distributed at the top. And for every partition, we're going to have 2 additional copies of it somewhere else across the cluster. So what happens if I'm writing data to partition 0, right? I'm going to connect to broker 0, write that data there, and then synchronously, in most cases, you can configure it otherwise, but synchronously, we're going to replicate that data over to the other 2 brokers where those replicas exist. Okay? So by the time the producer actually knows that the data's been written, we know it's been safely written to 3 brokers. All right? We have exact copies of it somewhere else. So now if a broker goes down, right, we've lost a full copy and a couple other copies of some other partitions, and that's a shame, right? For partition 0, that was a lead partition. That's the one that we were connecting to, that our producers were writing to and our consumers were reading from, right? So that's a shame. Those applications have stopped, right? They can't do their jobs anymore. At this point, the cluster is going to acknowledge that this node has gone down. It's going to realize. It's going to look at all the partitions that this broker was a leader for, and it's going to start looking for where it has copies, okay? And then it will rebalance. It'll do a leader election process, and we're going to find one of those copies and promote it to a leader so that now our producers and consumers can start connecting to, in this case, broker 1, and doing their jobs. All right? I know that was a bit of an aside, but again, for those of you who said you were new, this is a really important part of Kafka, and one of the really cool benefits of it as well, because Kafka is just pretty good at storing your data, right? Your immutable events in a resilient, a persistent, a distributed way for fast consumption, for moving those events quickly, and offering some cool data processing capabilities on top of that. All right, back to me. Okay. All right, so back to this survey application that we want to build, this recipe that we're going to follow. I already gave you a quick overview of this, so where do we start? Well, we need a Kafka cluster, right? That'd be the first place to start. So where do we get one of those? The store. Okay. I already told you this. I'm a lazy person. I hate maintaining my own infrastructure. I like using things in the cloud if I can. There are a ton of managed services out there for Kafka, so if you want to do something like this similar, just have a Kafka cluster running somewhere. You can use one in the cloud through Confluent if you want, or feel free to run it in Docker containers or just on your own machine, doesn't matter. But Confluent's pretty cool, I think so. We offer cloud-based Kafka fully in the cloud. I think it's really cool for projects like these where I'm just being exceptionally lazy. And on top of that, there are some cool tools you get out of this. We also have Kafka Connect, which is a great way to move data in and out of your Kafka cluster from places like databases or endpoints or whatnot. We have KSQLDB for in-browser stream processing that we'll be using a little later on. And we also have schema management just to maintain sort of the integrity of the data that we're putting into our topics. Okay? So have a Kafka cluster running. I don't care where you're doing it. Cool. Next up, let's get the data into Kafka, right? But hold your horses, right? I want to make sure that we understand what data we're actually working with. And I know, it's so exciting when you're building just a fun hobby project to just dive in and see what happens, throw caution to the wind. But I really, really like to take a step back and understand what data I'm working with. I find that it saves me a lot of time later on. I also am such a nerd, and I do maintain like a backlog of things that I want to do for each of my projects. So this is a good stage for me to actually determine what my long-term goals are for even a ridiculous project like this, and there are many long-term goals. So it's very beneficial to take a step back and understand what fields you think you need, and then argue with yourself to convince yourself you don't need those fields, add it to the backlog. And anyway, the result of this stage is really just building a schema, okay? Something that I could adhere to through the rest of the project. All right, so as I mentioned, Kafka works really well with schema registries. And so what this means is that for a given topic, you can assign a schema. This schema will reside in schema registry so that when a producer wants to write data to Kafka, it first needs to prove that this data actually adheres to that schema. then it's written to the topic, and then on the other end of things, when the consumers want to consume that data, they will throw an exception if it doesn't match the schema that they expect, right? So for schema registry, there are, within Kafka, there's a lot of different serialization formats that you can use. Avro, JSON, JSON schema, protobuf. It's really down to personal preference, honestly. I like using Avro. I don't know if anyone really says that, but I like using Avro. I like including it in my, I feel comfortable including it in my Python code, so that's what we're going to use here. So I wrote up a quick schema just to capture the meat of this project, right? The actual survey responses that I'm capturing from this application, okay? So pretty basic things, what survey ID are we working with? Which user is actually taking this? Give me some details on them, their name, their company, their location, and what is their actual response to this survey, all right? So the first complaint that you might have, if you are annoying like me, is that this is not normalized. This is kind of weird. I am a major proponent for normalizing your data, breaking it up into separate data sets where appropriate, and so tossing in this user data really kind of frustrates me, but rest assured this will be handled later on. We can actually extract this data using some easy stream processing once it gets into Kafka. The reason that I did include this data in one single schema is just for simplicity. It's being captured as part of the same process, right? And since if we wanted to write this data to 2 separate topics as a producer, yeah, we absolutely could, but then you run the risk of what if one message makes it and the other one doesn't, right? So it's safer in the long run to just include this in one single message and then extract it later on when I need it, okay? And we'll get a little more into that in a minute. So, but when I do want to actually extract this data, I should probably have schemas for those extracted data sets as well. So the first, just extracting the respondents, the users responding to this survey. These are my friends. This is overkill. They're like, why are you including company? Well, it's optional, okay? I don't need to know where you work. I know where you work. You've been there for 10 years. But anyway, if I wanted to extend this for, to other people that I know or people at conferences and bombard everyone with surveys, I could, right? I included these optional fields just to make the analysis a little more interesting down the road. Okay, and note that when I create this corresponding topic in Kafka, I'm going to make it a compact topic. So what that means is that it's basically the cleanup policy for the topic. So compacted topics say that we are going to maintain at least one value for every key. Okay, so the key in this case is my user ID, my individual respondent, and so we're always going to maintain one value for them. All right, we'll clean up all the old ones because they might not be necessary, but we're going to keep the latest value. Okay. And next up, the survey responses. So we can extract this as well, just the remaining fields that we need to flesh out. This is the survey, this is the user, and this is the response. All right. And on that note, what about the survey IDs, the actual survey questions these correspond to? So again, I have a much wider agenda for this. It's not just about Pi, believe it or not. I want to be able to issue, enable, and disable a bunch of different surveys and send them to my friends or my colleagues or, again, people out in the wild at conferences. So I wanted a way to keep track of all these survey questions that I would potentially be issuing. And the best way to do this is not in a Google Sheet, but in Kafka, okay? So I created another schema here just to maintain the actual survey questions that I would be issuing. And so we have the corresponding survey ID, we have the question, a summary just to make it a little more human readable when I'm looking at it later on, the actual responses, the options that people can respond to with, and whether or not it's enabled, right? For a Thanksgiving survey, it doesn't make sense that it would be enabled for 11 months out of the year. We only need it for 1 month of the year, basically. So having that flag means that I can turn these on and off and choose when these should be issued. Okay. This survey questions topic is going to be compact also, just like that respondents topic. Again, mostly because of that enabled flag, because if I want to update it, I really only care about the latest value for that field for that survey. All right. But for now, there's only one survey question in mind, and so we're going to write that to Kafka directly, and that is, what Pi is your favorite? Okay. I included a couple pre-canned options here, mostly because these are the pies that I'm good at making, and I didn't want them to get too unreasonable because my friends are unreasonable. All right, so we are going to write this into Kafka. This is an enabled survey. And so at this point, I know how all the data should look. I have at least this survey written to Kafka, and now we need to get the rest of it into Kafka, right? Let's start issuing some surveys. If you have seen some of my other content, you know that I love Telegram. How many of you use Telegram? Really? Okay, this is going to change your life. So cool. Yet another messaging application, right? WeChat, WhatsApp, whatever, add Telegram to the mix. It's really cool. The reason I like Telegram so much is that it has a really cool API attached to it so that you can actually define bots. And you can write your own bot and use that pretty rich API to then configure how people can interact with that bot. And then you can, I don't know, collect data and write it to Kafka. So it's pretty cool. I've used it in the past to receive alerts from Kafka and also use it as sort of an admin console for my phone so I can write data to Kafka without actually opening my computer, which is kind of nice. So I thought it would be kind of fun at this point to take Telegram, which is an application that most of my friends use anyway, and create a bot that would be accessible to all of them so that they can just open a conversation, see what surveys are available, and take one, right? Write it back to Kafka. So that they, I don't know, most of my friends don't know what Kafka is or care, right? So it's easier to say, hey, just chat with this bot, okay? I don't have to explain the rest of it to you. So again, very conveniently, there is this very rich API around Telegram, and there's a Python wrapper for that as well. So what this means is that you can just write a Python script, authenticate using an API key that you're given when you make that bot, and then outline the conversation handlers that people will follow to actually have a conversation with your bot, okay? And so getting into that a little bit more, so this is an example of a conversation handler that you would define. And again, this is sort of the high-level flow that someone would go through to actually converse with this bot. Okay? So it outlines how to actually start this survey, the different states and stages that you'll go through as you interact with the bot and have that full survey. And then, importantly, the functions or the message handlers that are associated with each stage of this conversation. Okay, so you're basically creating a finite state machine. I don't know if that actually makes it easier for any of you, but yeah, it takes a little bit of time to get used to this format, but then it's really fun to set it up. And then looking a little more closely into one of these individual message handlers. So here, I had just prompted the user for their name. And so I'm capturing that input, and I'm storing it in temporary state for the lifetime of this conversation, okay? And for this particular conversation handler, the lifetime of that. So I'm grabbing that, and then I'm prompting them for the next piece of information that I actually want to get from them, and that is optionally their company. And I'm giving them a way to go around it, skip if you don't actually want to give this information, which goes hand in hand with that being an optional field, right? And so this is how all of them work, right? You grab the information from their input, you forward it, you store it in state if it was given to you, you give them the next question, and then you forward them to the next stage, which is saying survey state company. So whatever response we actually get for this prompt, we're going to go handle it in that next message handler as well. And so once all of this information is actually captured, again, we're keeping it in temporary state. I will ask the user to confirm their responses. Does this look right? Do you want to update any of them? And then once they say it's wonderful, we go to the send function, right? We're going to take the state that we have captured. We're going to send it to the send entry function, and then use a producer, right? Serialize the data according to the schema that we defined earlier, and then use a serializing producer to then write that data to the broker. This is just a vanilla producer, a serializing producer. It is this simple. It is this easy. I did use a couple helper scripts to extract a little bit of the boilerplate code, especially for serializing producers, because you do have to specify where your schema registry is, how to connect to it, and whatnot. But that's just in one other file. It's pretty simple. I will have this linked at the end if you want to take a look at it. But yeah, the rest of the boilerplate code is handled by Telegram. Right? And so once you actually run this bot script, this is what you're going to see when you interact with that bot on Telegram, right? So I'm going to say, as a user, I want to take this survey, and so it's going to prompt for the name, give them an out if they really don't want to take this survey as well. Then from there, I'm going to input a name. I can enter the company, my location if I want, and then I get the survey question presented to me. And another cool feature in Telegram, they have easy ways to present information that you can select and respond with. So I thought it was cool that we had these buttons available, so I don't even have to rely on them mistyping the actual responses here. I'm giving them the options, and they just click on one and respond. Okay. And then here we've confirmed the information, and then from there, it's going to send it off to Kafka for me. All right. So back in November, when I actually ran this bot for the first time and annoyed all of my friends, this is the information that I saw. This is a screenshot from the Confluent Cloud Console, just showing all of the messages that were flowing through as they took this very annoying survey. Okay. Cool. So we have data being written. She no longer works for, no, she no longer lives in Florida, so I have to ask her to retake that. Okay. Anyway, so at this point, we have data in our cluster, right? We've connected our data sources. That's arguably the most difficult part, right? It's like machine learning projects where like 80% of it is just getting the right data, and then the rest of it's just whatever. All right, so now we can start the actual stream processing, the reason we're here for this, right? The actual survey analysis. So how do we process data with Kafka? Well, there's a bunch of ways. Thanks for asking. The OG way to do it is using the consumer and producer API. The cool thing about these is that they're available in pretty much all of your favorite languages, some of your least favorite. I love making that joke, but it's true. So they're really flexible, and that's one of the major benefits of this. But if you want to use the consumer producer API for stream processing, it's kind of a lot, right? You have to set up a consumer to read that data from Kafka, and then you start doing your stream processing, right? What are you actually trying to do? If it's stateless, cool. Do what you need to do, and then write it back to Kafka with the producer. Awesome. But what if it's stateful? Which it probably is, because that's way more interesting. Then that opens the door to a lot of other potential issues, right? What do you do if your stream processing application stops? What do you do with your state? Do you need to persist it? Does it matter? Do you need to actually keep track of like where you left off? There's a lot of extra questions that you have to ask yourselves. And so if you want to build more of a fault-tolerant stream processing application with the producer and consumer API, that's on you, right? There's a lot of extra steps you have to go into to make that work, okay? You know, this is a lower level option for stream processing. That's great. You're more flexible in what you can do, but proceed at your own risk, all right? So if you're a sane person, you're going to use one of the next two things. Moving up in ease of use is Kafka Streams. So this is a purpose-built Java and Scala library for stream processing with Kafka. All right. So its biggest win is that it takes that hassle of handling state out of your hair. You don't have to think about it. So what it does is it uses an in-memory local state to maintain that information, and then that information is also persisted back to a Kafka topic. Right? So if any of your application instances go down, you can reboot from that state, either locally if it comes back up on that same machine, or from the Kafka topic if it comes up somewhere else. Okay? And this is built on top of the consumer and producer API, so what that means is that we get that scalability, that parallelization of that processing that I talked about from the consumer groups. All right? So if we have an input topic with 10 partitions, and we could potentially spin up 10 instances of this same application, and each one would have one partition to deal with. Right? And then if one or two of them go down, then those partitions that they were managing are going to be rebalanced to some of the remaining running instances. All right? So that's all handled for you. The state will move with those running those input partitions, and you don't really have to worry about that. So. And then you get a lot of cool processing capabilities out of the box, filtering, aggregations, mapping, whatnot. But you can also do custom processors in there as well. So it's pretty awesome. Way better than the consumer producer API. And then finally, moving up in ease of use is KSQLDB. This is a SQL-like wrapper on top of Kafka Streams. So if Java's not your jam, and that's completely fine. Also, Kafka Streams and stream processing you can do. There's some Python libraries out there, so keep that in mind. But if that's not really what you want to do, then KSQLDB is a great option, right? So what this means is that you write a couple SQL statements, you create streams, you create tables, and then you have access to many of these aggregations and these stateful transformations from SQL, right? So you don't have to actually know really how to program. And what's really cool about ksqlDB is that I like that it makes stream processing available to more people. It's kind of fun. All right, so this is what I'm going to use. The real benefit, I think, of ksqlDB is that if you're using Confluent Cloud, it is available within the browser. All right, so I don't actually have to run any applications. Again, lazy. Cool. So ksqlDB. So the first thing you have to do is define your inputs. Okay, we need to load this information and give ksqlDB, tell them what data we're actually working with. And so ksqlDB has two main constructs. There are tables, there are streams. Streams represent ongoing series of events where every event that flows through is potentially relevant, right? So we want to be able to process that. Tables, on the other hand, they're like a compact topic. They only maintain the latest value per key, which is really valuable for a lot of use cases. So we'll get into that. But for right now, we're going to deal with these survey entries that we're actually getting from this Telegram application. And we want to bring this in as a stream, right? Because every entry is valuable, and we want to be able to process that. So that's going to be a stream. All right, so hence the create stream statement. We are giving it a very useful name, survey entries. And all we have to do is point to the Kafka topic where this data is and specify the value format. And so that is Avro, right? We used an Avro schema. And now I don't have to do anything else, which is really cool because ksqlDB, as a consumer, will look at this topic, this input topic, see the value format. It will go take that topic to the schema registry, fetch the schema for that topic, and then use that schema to parse all the fields and their types. So it's going to automatically do that for me. I don't have to risk all the ridiculous typos that I'm going to make trying to bring in all of these fields. So next, just to normalize the data, I just wanted to prove that this was happening. And there is a reason for this, right? I think it's a good best practice, especially if you're getting into maybe that sort of data mesh sort of approach and having data products, right? I am really the only consumer of this data. Sometimes, I guess, an intern accessed my data last year, but I'm usually the only person that deals with this data. But by normalizing this information, I can use it for any other application that I would want to, right? So if I want to have a really ridiculous, I don't know, like, I want to keep track of sort of like a phone book, where my friends are, what companies they work for, where they're located, whatever. I can do that because I'm extracting these respondents and I'm not relying on any of the survey data that's attached to it, right? And that's one of the main wins of Kafka, right? Is that this data is persisted so that any number of downstream applications can access it and make use of it in different ways, having that data product. So we're going to extract these respondents. Again, we're going to create a stream, and I'm just going to use a select statement to select the subset of fields that are actually relevant to me for the respondents topic, right? And these are the same ones that we wrote up in that original schema as well. Okay. So first thing to note here is that we are creating another stream here. We are giving it a useful name. We are going to specify which topic we want to store this data in now. Right? The first time we did this, it said, this is the topic we're going to get the data out of, but this one, we're going to store the data back to the survey respondents. We specify the Avro format, the value format again, and then we're doing that select. So if I just took this select statement and executed it in ksqlDB, it's going to execute this on all the data we have in the topic right now, and then it's going to stop. That's cool for debugging purposes, but that's very not useful in my case because these survey entries are going to continue to flow in, right? And every time a new one comes in, I want this to be executed. I want to extract this data, okay? So what we're going to do is we are going to add emit changes at the end. And so what this means is that every time a new piece of information flows in on that incoming topic, we're going to execute this, and we're going to take the result, and it's going to be appended to that create streams. Right, it's going to be appended to that survey respondents stream for us. And this is called a push query. This is contrasted with a pull query where we're just, like I said, executing that select statement and getting what we currently have. All right, we're going to do the same thing with the survey responses data. I'm just selecting a subset of the fields that I need. So in this case, we have selected the respondents, we've selected the responses, and now they're available within this ksqlDB application. What else do we need, though? Well, we need the survey questions, right? So this is the last data set that we actually need to bring into the application. For the last few data sets, we used a create stream statement because every event was potentially relevant. In the case of the survey questions, though, right? It's built on top of a compact topic, right? So we're already intermittently sort of compacting that data and only keeping the latest value. But I really want to ensure that we only have the latest value, right? In case that enable flag was turned off and I want to include that, or maybe I've updated some of the values as part of this survey. So we're going to use a table here, okay? So again, because we have this Avro schema backing this topic, I don't have to specify any of the fields, but I have an ID there, right? So tables need to know which ID, which key is going to be used for this table. Right? So you just have to specify one of the fields so it knows which one is going to be overwritten, right, with the values. All right. So between the create table and create stream statement, not really any differences. We point to the topic where this data is and the value format. Right? Cool. All right. All that remains to be done is actually analyze this, right? Let's do something useful with this data, okay? And really the only thing I was interested in was the aggregate of this information, right? I want to know how many people are voting for each of these options. And KSQLDB makes this pretty easy with the histogram function. It's built in. So all I'm doing here is I'm selecting the question and grouping by that. And then I'm creating a histogram of the responses. Again, we're doing emit changes so that every time a new survey entry comes in, we're going to build a new histogram, and we're going to output it to this create table, survey results live. It is a table, so it is going to overwrite that key, for that survey question after a little bit of time, but we are going to get all of the results here, okay? So this is an example of the output that I would see as these results were flowing in. So you see the first one, we had 1, 1, and 3. Then we had a new one come in, a vote for apple pie. That's going to be updated. Then we had someone vote for pumpkin pie, and so on and so forth, right? So I'm going to see all of these partial responses in this way. But what if I didn't care about that? But Danica, we spent the whole time talking about real-time results. Well, I don't want this alert on my phone every time someone takes a survey. So there's being reasonable and capturing all the data, and then there's saving space on my phone. Anyway, so here's again that survey, or the SQL that we executed for this. So what if I only want to see these results at the end of a very artificial, unreasonable 2-day deadline that I give my friends? Well, easy. We're going to add 2 lines to this. The first is we're going to define a tumbling window, so a non-overlapping window of 48 hours. We're going to give them 10 extra minutes just for late events, right? So now, when these events flow in, when these surveys flow in, the first thing we're going to do is group it within this window based on the timestamp of when that event was taken, survey was taken. And then we're going to start executing that histogram within that window. So that state's only going to be valid for that 48-hour period, okay? And then instead of using emit changes, right, because emit changes, every time something comes in, we're still going to get those partial results, I'm going to use emit final, which says, wait until the window closes before you give me the final result. Okay? So I can have both of these running, both of these SQL statements running. I can get that real-time output of that information, but for the purposes of sending this information directly to my phone and getting my final shopping list of what I actually need to go get at the store, I'm going to use this final statement to know when that survey window has finally closed. And you might be saying to yourself, oh, that's great, the data's in Kafka, but the data's in Kafka, and I need it in the real world, in my phone. So let's migrate it out. I mentioned earlier this thing called Kafka Connect, which is your really good way to move data in and out of Kafka to different data sources, data sinks. So think databases, S3, Elasticsearch, wherever you want to move this data, there's probably a Kafka connector that exists already to help you do that. And that's the cool thing, is that these connectors are pre-made in most cases, unless you have an in-house sort of database that you want to use, which you totally can write your own. But because they've already been written, it's a configuration-driven technology. So you run Kafka Connect alongside your Kafka cluster, and then you set up a configuration to define your source connector or your sink connector to move data out, and then you hit the ground running, right? You're ready to go. It's going to start moving that data for you, okay? A lot of these connectors, there's like 200 of them, and like 70 of them are available within Confluent Cloud fully managed, meaning that you don't have to run your own Kafka Connect cluster. You just run it through Confluent Cloud. And one of those connectors is the HTTP sync connector. So that one, what you need is an endpoint, and then you can send data from any Kafka topic to that endpoint. Well, let's get an endpoint. Well, so with the Telegram API, right, I have that API key to authenticate my bot, and I can use that to get the unique conversation ID that I'm holding with my bot. And with those two things together, then I can build up an endpoint that will send messages directly to that conversation. All right? So I can use that full endpoint, use that in the configuration for the sync connector, point to the Kafka topic that I want to move the data from. And once I bring this up, the data, as these results are coming through on that topic, they're going to be sent to my phone, and this is the message that I see. It's just a bunch of emojis. I wanted it to be kind of fun. I did a little bit of finagling between the survey results final topic and this stage, obviously, but it's pretty much the same data. So as soon as this window closes and that result is emitted to the survey results final topic, the connector is going to pick that up and send this directly to my phone. All right. Yeah, and in this case, I made pumpkin pie and apple pie, and most people were happy. Awesome. All right. So as a summary, in case you forgot, we learned some things today. I know it probably was hard to tell, but you saw a couple cool things with Telegram. Only one of you said you use Telegram, so I think the rest of you should play around with it. It's kind of fun. But we saw how to use Telegram as a producer. Right? For people who don't care about Kafka or don't want to leave their phones for things, that's a pretty nice way to move data into Kafka. We saw a bit about stream processing, specifically what you could do with ksqldb in a quick way. You saw a glimpse of Kafka Connect again to move that data out of Kafka and back to my phone. And just to really drive it home, every streaming data pipeline that you would want to build with Kafka is going to use some of these components. Right? You need a way to get data into Kafka. You're either going to use Kafka Connect as a source connector, or you're going to use a producer. You need to do stream processing. You're either going to use ksqldb, Kafka Streams, or the consumer producer API. And to move data out, again, you're going to use a connector, or you're going to use a consumer API. And you're going to do that again and again and again and make interesting things. Okay? So really, that was my gift to you. You had some cool tools at your disposal now. And in case I do have a couple minutes left, but let's not forget the important part of this, why we're here. At the end, the final stage is actually baking something and making a human happy. All right. If you want that recipe, you will have to follow me on Twitter. That's my shameless plug. But the other cool thing, let's talk about my backlog, right? What other cool things could we do with this to make this a little more interesting, right? I'm so glad you asked. So the first thing we could do is flesh out that Telegram application. Right? Make it be useful as, like I said, an admin console, right? So then I could issue surveys right from my phone and annoy people even more, right? And update, maybe enable and disable these surveys, just again, without logging in. To do this, I'd follow a similar approach as we did with the producer for the general conversation flow. I would just add another conversation. Within that, I would authenticate that I am the actual user that serves as the admin that has access to it. So I'd validate my conversation ID, capture the updates, send it to Kafka. And then there's no stopping me, right? We could add a consumer to the main part of the Telegram application and then send these surveys directly back to my friends, right? I could have that be a push model and just annoy them every time I send a new one, or I could have them actually decide to take a new survey and request what surveys are actually available before they take them, right? And so what that means, surveys all the time, right? Not just pie, but what should we have at the next dinner? When are you available to hang out? Please, talk to me, So yeah, it's just the fun will never end. I could also do something similar on the admin console side, right? Add a consumer to this component. And so it wouldn't only be push analytics, right, where I'm getting that message from the result of that Kafka connector, but I could also request these analytics, right? Show me what the current responses are, the results are for this survey, and get that printed out as the admin, right? I could also give anyone access to those things so that if they're curious, they can see the results of the current surveys, right? Anyway, just a couple more fun things. This is only the beginning, truly. Like I said, this is a framework. This is a recipe of sorts, a way for you to use this as inspiration to have a little bit of fun with Kafka. And one last final plug, speaking of recipes. So because of the usefulness, absolutely usefulness of survey analysis in real time with Kafka, I did adapt this presentation to something that we call stream processing use case recipes that we have hosted on Confluent Developer, which is our developer portal. So this is just one of dozens and dozens of these use cases that we have, and they're fully launchable, They're written in KSQLDB. Many of them are written in Kafka streams as well. So if you are, whatever industry, they span so many industries and use cases, it's a cool place to go and just see what you can do with Kafka, because you might not even be aware of some of the cool use cases that you can cover with real-time streaming. So I encourage you to take a look at those. They're kind of fun. If you're a learn by doing person, this is exactly the place that you should go to learn more about Kafka. And with that, here are my links. I have a link back to this recipe if you want to take a look at it in the wider developer portal, and then also some of my source code there as well. So, all right, we've got 10 seconds. Who has questions? Thank you. Appreciate you being here. Thanks.